According to NEC 240.21, the tap conductor must have an ampacity not less than the ampacity of the branch circuit overcurrent protective device. In the situation presented, the branch circuit overcurrent protective device is the 400 amp breaker in the pump panel. The question revolves around whether the next standard size rule can be applied to size the tap wire, specifically using 500 MCM cable, which is rated for 380 amps at 75 degrees Celsius for a 400 amp breaker. The answer is yes, the next standard size rule can be used to size the tap wire in this scenario. NEC 240.21 outlines the requirements for tap conductors. In essence, a tap conductor is a conductor that is tapped from a larger feeder or main. The key considerations for tap conductors are their ampacity, length, and overcurrent protection. The general rule is that the tap conductor must have an ampacity sufficient to carry the load it serves. However, specific exceptions and rules apply, particularly when dealing with industrial installations. When you are dealing with tap conductors, there are some things that you want to keep in mind. Firstly, you want to make sure that the tap conductors must not exceed 10 feet in length. Secondly, the tap conductor's ampacity must not be less than the combined calculated loads on the circuit supplied by the tap conductors, and secondly, the tap conductor's ampacity must not be less than the rating of the device or overcurrent protective device supplied by the tap conductors, or not less than the overcurrent protection at the tap conductor's termination. In accordance with the NEC, if there isn't a standard wire size for exactly 400 amps at 75 degrees Celsius, the next standard size can be used, like 500 MCM. Although 500 MCM is rated for 380 amps at 75 degrees Celsius, which is less than 400 amps, it can be considered sufficient for the application due to the next standard size rule. The next standard size rule allows you to use the next larger standard conductor size if the conductor ampacity does not correspond to a standard rating of overcurrent protection devices. This is permitted in specific cases where the calculated load does not exactly match the available standard conductor sizes. In this instance, 500 MCM copper conductor is rated for 380 amps in the 75 degrees Celsius column, which meets the requirement, even though it is not directly rated for 400 amps. Therefore, the tap wire 500 MCM can be used to supply the 400 amp pump panel. It's important to confirm the ampacity of the conductors and the appropriate temperature rating. Conductors have ampacity ratings based on their insulation type and the ambient temperature in which they are installed. Typically, the 75 degrees Celsius column is used for terminations rated for 75 degrees Celsius, which is common in many electrical panels and equipment. If the terminals are only rated for 60 degrees Celsius, you would need to use the 60 degrees Celsius ampacity column. Standard conductor sizes are based on the American wire gauge, or AUG, and 1000 circular mils, or MCM system. These sizes have associated ampacity ratings as specified in NEC Table 310.16. For example, common sizes include 12 AWG, 10 AUG, 8 AWG, 6 AUG, 4 AWG, 3 AWG, 2 AUG, 1 AUG, 1/0, 2/0, 3/0, 4/0, and then MCM sizes such as 250 MCM, 300 MCM, 350 MCM, 400 MCM, 500 MCM, 600 MCM, 750 MCM, and so on. The specific ampacity of each size depends on the insulation type and temperature rating. The pump panel contains the motor starter and other control components necessary for operating the pump. It typically includes an overcurrent protection device, such as a circuit breaker or fuses, to protect the pump motor and associated wiring from overloads and short circuits. The MCC, or Motor Control Center, is a centralized assembly of motor starters, circuit breakers, and other control devices used to control and protect electric motors in industrial and commercial applications. The MCC provides a convenient and organized way to manage multiple motor circuits, and it often includes a common busbar system for distributing power to the various motor starters. The bus bars in the MCC act as the main power distribution point, providing a low impedance path for current to flow to the individual motor starters. Tapping from the bus bars allows for a direct connection to the power source. Here are the steps for determining the correct tap conductor size. Firstly, determine the load requirements, so calculate the total load that the pump panel will draw. This includes the pump motor's full load amps, or FLA, as well as any other loads connected to the panel. Secondly, select the overcurrent protection device. Choose a breaker of fuse size that is appropriate for the load and complies with NEC requirements. In this case, a 400 amp breaker is used. Thirdly, consult NEC Table 310.16. Find the appropriate ampacity for the conductor based on its insulation type and temperature rating. For example, THHN or XHHW conductors are commonly used. Fourthly, apply the tap rule requirements as per NEC 240.21. Ensure that the tap conductor's ampacity is not less than the calculated load and not less than the rating of the overcurrent protection device. Fifthly, consider the next standard size rule. If the conductor ampacity does not match a standard overcurrent protection device rating, you may be able to use the next largest standard conductor size as allowed by the NEC. Sixthly, verify the terminal temperature ratings. Make sure that the conductor's temperature rating is compatible with the terminals in the NCC and pump panel. Use the appropriate ampacity column, typically 75 degrees Celsius, for terminations rated for that temperature. Seventhly, install the tap conductors. Properly terminate the tap conductors in the MCC and pump panel, ensuring secure connections and compliance with all applicable codes and standards. In some cases, an engineer may be needed for complex electrical installations, and always seek professional assistance. NEC 240.21 provides specific rules for tap conductors, and these rules vary depending on the application and installation conditions. It is important to carefully review and understand these rules to ensure compliance with the NEC. Tap conductors must be protected from physical damage. This may involve using conduit or other protective measures to prevent damage to the conductors. Tap conductors must be installed in a neat and workmanlike manner. This includes properly supporting and securing the conductors and avoiding unnecessary bends or splices. Make sure to label the tap conductors to identify their source and purpose. This helps with troubleshooting and maintenance in the future. The tap conductors must be grounded in accordance with NEC requirements. This helps to prevent electrical shock hazards and ensure proper operation of the electrical system. All electrical work must be performed by qualified personnel who are familiar with the NEC and other applicable codes and standards. It's important to ensure safety when doing all electrical work. Always de-energize the circuit before working on electrical equipment. Use appropriate personal protective equipment, or PPE, such as gloves and safety glasses. Follow lockout-tagout procedures to prevent accidental re-energization of the circuit. If you are unsure about any aspect of the electrical installation, consult with a qualified electrician or engineer. There are specific requirements for the overcurrent protection of tap conductors. These requirements vary depending on the length of the tap conductors and the size of the overcurrent protection device. When using the next standard size rule, it is important to consider the overall design and coordination of the electrical system. Ensure that the overcurrent protection devices are properly coordinated to prevent nuisance tripping and provide adequate protection for the equipment. It is essential to maintain accurate and up-to-date documentation of all electrical work. This includes drawings, specifications, and test reports. This documentation is important for future maintenance and troubleshooting. The NEC is updated every 3 years, so it is important to stay current with the latest edition of the code. This ensures that you are using the most up-to-date and accurate information for your electrical installations. Common conductor insulation types are THHN, THWN, THW, XHHW, and RHW. Each insulation type has different temperature ratings and suitability for different applications. Selecting the correct insulation type is important for ensuring the safety and reliability of the electrical system. The ampacity of a conductor is the maximum amount of current that it can carry continuously without exceeding its temperature rating. The ampacity of a conductor depends on its size, insulation type, and installation conditions. The National Electrical Manufacturers Association, or NEMA, provides standards for electrical enclosures, equipment, and components. These standards help to ensure the safety and compatibility of electrical products. The Institute of Electrical and Electronics Engineers, or IEE, provides standards and technical information for the electrical and electronics industries. These standards cover a wide range of topics, including power systems, electrical safety, and electromagnetic compatibility. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electrical shock hazard. An electrical plan review involves submitting electrical drawings and specifications to the local electrical inspector for review and approval. The inspector will review the plans to ensure that they comply with the NEC and other applicable codes and standards. An electrical permit is required for most electrical work. The permit provides authorization to perform the work and allows the electrical inspector to inspect the installation to ensure that it complies with the code. The electrical inspector is responsible for enforcing the NEC and other applicable codes and standards. The inspector will inspect electrical installations to ensure that they are safe and comply with the code. The pump motor is a critical component of the pump system. It is important to select a motor that is properly sized for the load and that meets all applicable codes and standards. The motor starter is used to start and stop the pump motor. The motor starter provides overload protection and other control functions. The overload protection device is designed to protect the motor from overheating due to excessive current. The overload protection device will trip and shut off the motor if it detects an overload condition. Short circuit protection is designed to protect the electrical system from damage due to short circuits. Short circuit protection devices, such as circuit breakers and fuses, will quickly interrupt the flow of current in the event of a short circuit. The available fault current is the amount of current that is available at a given point in the electrical system during a short circuit. The available fault current must be considered when selecting overcurrent protection devices to ensure that they have sufficient interrupting capacity. Selective coordination is a design approach that ensures that only the overcurrent protection device closest to the fault will trip, while other upstream devices remain closed. This helps to minimize the impact of a fault and maintain power to other parts of the electrical system. Arc flash is a dangerous electrical hazard that can occur during a short circuit or other electrical fault. Arc flash can cause severe burns, blindness, and even death. Arc flash studies are performed to assess the arc flash hazard and to determine the appropriate personal protective equipment, or PPE, requirements. The proper PPE for electrical work includes safety glasses, gloves, and flame-resistant clothing. The specific PPE requirements depend on the voltage and current levels of the electrical system. Lockout-tagout procedures are used to prevent accidental re-energization of electrical equipment during maintenance and repair. Lockout-tagout involves disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch. The NEC contains specific requirements for the installation of electrical equipment in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Electrical equipment installed in hazardous locations must be specially designed and approved for use in those areas. A ground fault circuit interrupter, or GFCI, is a device that is designed to protect people from electrical shock hazards. GFCIs detect ground faults and quickly interrupt the flow of current, which can prevent serious injury or death. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning, switching, and other events. SPD divert the surge current to ground, which helps to prevent damage to sensitive electronic equipment. Harmonics are distortions of the voltage and current waveforms in an electrical system. Harmonics can cause a variety of problems, including overheating of equipment, misoperation of electronic devices, and increased energy costs. Power factor is a measure of how efficiently electrical power is being used. A low power factor can result in increased energy costs and reduced system capacity. Power factor correction can be achieved by installing capacitors or other equipment to improve the power factor. A qualified electrical contractor has the experience and expertise to perform electrical work safely and correctly. A qualified electrical contractor will also be familiar with the NEC and other applicable codes and standards. When selecting an electrical contractor, it is important to check their qualifications and experience. You should also ask for references and check their insurance coverage. Regular maintenance is essential for ensuring the safety and reliability of electrical equipment. Regular maintenance should include inspecting equipment for damage, cleaning equipment, and testing equipment. Electrical safety training is important for all employees who work with or around electrical equipment. Electrical safety training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. The 500 mcm conductor is a large conductor that is typically used for high current applications. The 500 mcm conductor has a large cross-sectional area, which allows it to carry a large amount of current without overheating. The 500 mcm conductor is available in a variety of insulation types, including THHN, THWN, THW, XHHW, and RHW. The specific insulation type will depend on the application and the environmental conditions. The 500 mcm conductor is typically terminated using compression connectors or mechanical connectors. Compression connectors are crimped onto the conductor using a special tool. Mechanical connectors are tightened onto the conductor using screws or bolts. When terminating the 500 mcm conductor, it is important to follow the manufacturer's instructions and to use the correct tools and techniques. Improper termination can result in overheating and failure of the connection. The 500 mcm conductor is typically installed in conduit or cable tray. Conduit provides physical protection for the conductor and helps to prevent damage. Cable tray provides support for the conductor and allows for easy access for maintenance and repair. When installing the 500 mcm conductor, it is important to follow all applicable codes and standards. The NEC contains specific requirements for the installation of conductors, including requirements for spacing, support, and protection. The cost of the 500 mcm conductor will vary depending on the size, insulation type, and quantity purchased. The cost of installation will also vary depending on the complexity of the installation and the labor rates in the area. When planning an electrical installation, it is important to consider the cost of the materials and labor. It is also important to obtain multiple bids from qualified electrical contractors. This will help to ensure that you are getting the best price for the work.